Okay, welcome to video 1.3a, Significant Figures. I posted another video online that I did not create. It was by a professor, and she went over how to do scientific notation. She also went over things like how to, what units of measurement were for different types of matter, like volume is measured in liters, and mass is measured in grams, and length is measured in centimeters. So go ahead and watch that video if you haven't done so already. This video on sig figs, I didn't find a good one for you to watch, so I'm going to go over it with you real quick. A lot of students find some difficulty with significant figures, but I'm going to try to be as clear and concise as we can. Okay, so let's talk about what the heck a significant figure is. A significant figure is used by scientists to determine how precise a measurement is. When we measure things with a meter stick or a graduated cylinder if we're measuring volume, or a balance if we're measuring mass, the device itself has a certain percentage or a certain amount of uncertainty to it. So significant digits are digits that we know for certain are absolutely true. So significant digits are measured to include all of the known digits that you see on your measuring instrument, and we have one estimated digit. I'm going to show you how that works. Alright, let's take a look at the ruler below. When we go to measure something with a ruler, you can see this little pointer thing here. Let me get a little pointer out so we can we'll use green. Right there is where we're measuring to. Okay, and if you were measuring on a ruler with this, and these are centimeters, you would say that it was about 13 centimeters, and then you have 0.1, 0.2, 0.3 centimeters. So you have 13.3 centimeters. Well, those are the numbers that we know for certain. We know that it's 13.3 centimeters. When you're using significant figures, you just estimate the next digit. So it's 13.3, and then because it's right on that line, it's going to be 13.30, and that gives us our measurement for that particular length of whatever it is we're looking at. This works for every single type of measuring device that we use in science. If you're using a balance and the balance reads 14.2, then you would write 14.20 because the following digit is estimated. The last digit is estimated. Okay, crumb cakes. I just recorded, or didn't record, myself talking to myself. Okay, so on this one we also have a ruler that we have laid out before us, and I can zoom in, which is really kind of a cool thing with this program. And when we go to read on this ruler, we start with the 12. See, this is 12 centimeters. That's this line right here. Each one of these little bumps, okay, these little lines in between, is a 0.1. So we have 12, 12.1, 12.2, 12.3, and so on and so forth. So this line is going to be 12.5, 12.6, 12.7, and 12.8. Now, we know that this measurement is between 12.8 and 12.9. 12.8 would be a certainty, okay? But because it's between 12.8 and 12.9, we can estimate that last digit to be about halfway in between. So we can say that this is 12.85. And if you zoom back out, okay, what can you read before the estimate? We could read with certainty that it was 12.8. Now we're going to estimate the last digit, and that's 12.85. So 12.85 is our number that we would use for our calculations. Anytime you have a measuring instrument, be it a ruler, a balance, a graduated cylinder, all the same rules apply. So if we measure something and it comes out to be 3.5, because my my balance goes by 0.5s, then we go 3.50. We're going to estimate that final digit. Okay, let's try one on a graduated cylinder. The graduated cylinder, the units are given to us. Whoops, let's zoom in here. The units are given to us. We have 50 milliliters right here, and we have 60 milliliters right here. So somewhere between the 50 and the 60 is my measurement. And each one of these lines is a 0.1. I'm sorry, it's not a 0.1, it's a 1. So 50, 51, 52, 53, 54, 55, 56. So now I know that the bottom of my meniscus is resting at 56 milliliters. Alright, so we have 56 milliliters that we know 100% that's what it is. We're going to estimate the last digit, so we get 56.0 is our measurement for this particular fluid in the graduated cylinder. I'm going to zoom back out, and I want you to pause the tape, and I want you to make yourself some notes in your notebook on reading a graduated cylinder and understanding how we read that graduated cylinder. Okay, here's one more for practice. Let me zoom in so that we can see. Again, we're between 50 and 60 milliliters. Get my pointer out again. So if this is 50, this is 51, 52, 53. So 53 is what I would know for certain. 54 is right here. So 53 is a certain measurement. It's what I read exactly off of the graduated cylinder. So because it's in between, we can go 53.5 as our measurement from this particular graduated cylinder, because that 0.5 means that it's halfway between 53 and 54, and that's the one that I'm estimating. In your interactive notebook, I want you to write down the definition of significant figure. So pause the tape and write this down. Okay, now that you got that into your notebook, now we have some rules for significant figures, because not all the time are we going to be looking at measuring instruments. We might be looking at just numbers on a page. And when we look at numbers on a page, we have to be able to determine how many figures, how many numbers in the number that we're looking at are significant. So there's a series of rules, and they're really not that hard, but we have to understand them. So let's take a look at rule number 1. Rule number 1 says all non-zero digits are always significant. Write that in your interactive notebook so that you have it. Okay, now that we got that in our notebooks, let's talk about what a non-zero digit is. A non-zero digit number is any number that is not a zero. So it could be the number 1, 2, 3, 4, 5, 6, 7, 8, or 9. It is not a zero. Those are the only digits that we have to work with, from 1 through 9. So when you look at this number right here, 274, there are 3 significant digits in that number. 2 is a significant digit because it falls between the numbers 1 and 9. 7 is a significant figure because it is again between the numbers 1 and 9, and 4 is a significant figure. So there's 3 significant figures in this particular number. 3 significant figures. There are no zeros here, so they're all significant. All 5 of these numbers are significant digits. And finally, this one has 4 significant figures. Write those down so you have examples. Draw yourself little arrows so you understand that this one has 3, this one has 5, and this one has 4. Okay, now we have to talk about zeros. And zeros can happen in 3 different places. This is how I think of it. Okay, zeros can show up in the beginning. They can show up between non-zeros, or they can show up at the end. Well, we're going to go with rule number 2, where the zeros are between the non-zeros. So here we can see 7 is a non-zero, so that's significant, because remember, all numbers between 1 and 9 are significant, and 3 is a significant number. So these zeros in between are between significant digits. 7 is significant, 3 is significant. If the zeros are sandwiched between significant numbers, or numbers that are between 1 and 9, they are counted as significant digits. So this one happens to have 4 significant digits. This guy down here has 1 0 that's sandwiched between a 4, which is significant, and a 9 that is significant. So that number, 40.9, has 3 significant digits. Make sure that you pause me and write down rule number 2 in your notebook. Okay, the next place that a 0 can show up is in front of a non-zero digit, which means they happen to the left of before any significant digits show up. So see these zeros right here? They're to the left of significant digits. So these are called initial zeros. Initial zeros, zeros that appear in front of a non-zero digit, are never, ever, ever significant. You don't count them. So these zeros, let me get a pen out. This one, whoops, I don't want to write in black. This one, this one, this one, and this one are not significant. So the only numbers that we count when we're asked how many significant figures there are 2. Okay, now let me erase this so we have some room. Okay, the next example has only 1 digit, or 1 0 in front, and that 0, let's make that go away, ugh, yuck, that 0 is not counted. So this number, 0.453, has 3 significant digits. Take a moment and write rule number 3 in your interactive notebook. Okay, rule number 4. We covered rule number 2, which is zeros that are sandwiched in between significant digits. We covered the zeros that come in the beginning, before any significant digits. Now we have to talk about the zeros that are at the end, which means they are on the right side of any number. So right here, see how these zeros are on the right side of the significant digits. So, when do you count them? Those zeros only count if you can physically see with your little eyeballs a decimal point. Now this number right here has a decimal point right there. Because I see it, I count those zeros. If there were no zeros, no decimal point, let's write it down. Let's say it said 4300, and there's no decimal point in there. See? I don't see any decimal point there. There's no decimal point there, or there, or there, or there. Because there's no decimal point, those zeros don't count. If you do see a decimal point, the zeros count. So in this particular case, right here, there's 4 significant digits. In this case, there would only be 2 significant digits. Alright, let's take a look at this example, this 1.010. In this case, we have numbers 1, 0, 1. The 1 and the 1, these two 1s are significant. The 0 sandwiched in between is significant. We do count that because it's sandwiched in between. That was rule number 2. This 0 at the end on the right-hand side is significant only if I see a decimal point. Well, voila, there it is, that little decimal point. And because that decimal point is there, that 0 is counting. That's why you have 4 numbers. Okay, last one. This one is significant because it is a non-zero digit. 5 is significant because it's a non-zero digit. That's rule number 1. And this 0 right here is significant because there is a decimal point right there where my little red dot is. Okay, so it has 3 significant digits. Take a moment and write down rule number 4. Okay, so on this page we're going to discuss the rules for doing math using the significant figures we just talked about in the beginning of this video. So just to reiterate one more time, we talked about how we are going to measure significant figures or significant digits, where they come from, with measuring using a measuring instrument, a ruler, a balance, a graduated cylinder, etc. Then we talked about how do you know how many significant figures a measurement is going to have when you just look at the number written on a page. So we went through the 4 rules for doing that. Now we're going to take those numbers and we're going to multiply and divide them, and then we're going to add and subtract them. So the first rule that we're going to do is the multiplication and division rule, and in that one, your answer, whatever answer you get when you multiply or divide numbers, can't have more significant figures than the number of significant figures in the problem. So let me give you an example. Down here, let's break out a pointer. Who knows what I have? A pointer or a red laser thing. Alright, so we got this number right here. That number has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 significant digits. Okay, I counted this 0 because it's sandwiched in between. That was rule number 2. So this has 10 significant digits. Let me just write that down for us. Break out my little pen. Alright, so, of course, it's in a different color. Alright, so that has 10 sig figs. This number right here has 4 significant figures. Our answer cannot have more than 4 significant figures when we are done. So we're going to plug these numbers into our calculator, and the calculator is going to give us this number. Remember, a calculator is just a machine, okay? It just does the calculation for us. That number has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 significant figures. Well, we can't write 10 significant figures down. So whenever somebody asks me, oh, what do I round to? I could always point them to the significant figure rule, okay, that we're talking about now, or I could just say round to the nearest tenth, round to the nearest hundredth, so on and so forth. If we're doing science the correct way, the rule is with multiplication and division, you can only have the number of significant figures that you have in the lowest number when you started. So in this case, this number, 35.25, only had 4 significant figures. So our answer can only have 4 significant figures. So what I will do is I will round this so that it only has 4 significant figures. And that would bring us to 2, 1, 3, 4. And then this 0.8 would make this 4 round up to a 5. So my answer would be 2,135. Take a few minutes and write this down in your notebook so that you understand how to multiply and divide using significant figures. Okay, the second math rule for significant figures is adding and subtracting, and that rule is a little bit different than the multiply and divide. With adding and subtracting, answers can have more numbers to the right of the decimal point than the number in the problem, with the least amount of numbers to the right of the decimal point. Okay, what does that mean? Let's look at this example. This example has 1 number to the right of the decimal point. This number has 2 digits to the right of the decimal point, and this one has 2 digits to the right of the decimal point. When I add all these numbers up, my calculator says I get 29.68. Well, because this only had 1 digit to the right of the decimal point, and these guys had 2 digits to the right of the decimal point, then my answer can only have 1 digit to the right of the decimal point. So my answer would be 29.7. Let me erase this stuff so that you can write this all down in your notebook. Okay, so take a minute and write all this stuff down. Okay, so I know that this stuff is not the easiest, and I know significant figures are confusing to a bunch of people, but I hope this video helped. So you should be able to read the instrument, the measuring instrument, the way it's supposed to be read at this point. Remember, we always estimate 1 digit past what the instrument tells us. We know the rules for how to determine how many significant figures a number has, and we also learned 2 math rules: how to multiply and divide, and how to add and subtract using significant figures. Until next time.